Find the x-intercept and the y-intercept of the line below. So the x-intercept is the place where the graph touches or passes through the x-axis, whereas the y-intercept is the place where the graph touches or passes through the y-axis. So you notice that there's no point where the graph touches or passes through the x-axis, so there's no x-intercept. Now we look for the place where the graph touches or passes through the y-axis, and that would be at +4. So our y-intercept would be at the point 0, 4. Find the x-intercept and y-intercept of the line 3x plus 2y equals -6. So to find the x-intercept, we set y equal to 0 and solve for x. And then to find the y-intercept, we're going to set x equal to 0 and solve for y. So we have 3x plus 2y equals -6. So to find the x-intercept, we're going to substitute 0 in for y. So we have 3x plus 2 times 0 equals -6. 2 times 0 is 0. And 3x plus 0 is 3x. And then we'll divide both sides by 3. And our x-intercept would have the coordinates -2. And remember, we substituted 0 in for y. So -2, 0. So to find the y-intercept, we go back to our original problem, and this time we substitute 0 in for x. So we'd have 3 times 0 plus 2y equals -6. 0 plus 2y equals -6. 2y equals -6, and then we're going to divide by 2, so y would equal -3. So the coordinates of our y-intercept, remember, 0 for x and -3 for y. The equation of the line is given below. 4x plus 6y equals -12. We're asked to find the x and y-intercept, then use both the x and y-intercept to graph the line. So remember, when we're finding the x-intercept, we're going to substitute 0 in for y. So that gives us 4x equals -12, and we're going to divide by 4. So x equals -3. So the coordinates of our x-intercept would be -3, 0. And to find our y-intercept, we're substituting 0 in for x. So we have 4 times 0 plus 6y equals -12. Which gives us 6y equaling -12. And then we divide by 6, so y would equal -2. So the coordinates of our y-intercept would be 0, -2. So we're going to plot those 2 points on our graph and then connect the points with a straight line. So our x-intercept, remember, that's the place where the graph touches or passes through the x-axis, is at -3, 0. And our y-intercept is at 0, -2. And again, that's the place where our graph passes through our y-axis. So now we've plotted our two intercepts. So we're just going to connect these 2 points with a straight line. For our next example, for each line, determine whether the slope is positive, negative, 0, or undefined. So when we're looking at our lines, if we have a vertical line and we look at just any 2 points on the line, so the change in the rise for this example where I placed the 2 points would be 1. And the change in the run, how far do I move left or right? I moved 0. So for all vertical lines, we'd end up with a denominator of 0, which would make our slope undefined. So a vertical line has a slope that's undefined. So let's look at line 2. So again, I can just put 2 points on for just example purposes. So the change in the rise in this case would be 0. The change in the run would be 1. So when we have a fraction in our numerator 0, the value is 0. So for all horizontal lines, our slope would be 0. Now, when we look at line 3, you notice as you move from left to right, our graph is moving downwards. So it's decreasing, which means our slope would be negative. So line 4, as we're moving from left to right, our graph is increasing, getting higher. So therefore, we would have a positive slope. Find the slope of the line graph below. So the line has a point 0, -1, and also at 4, 4. So there's a couple of ways that you could find the slope. The easiest way is just to count. How do we move? How much rise and what's the run as we move from one point to the other? So we notice that this graph is increasing as we move from left to right. So we know our slope is going to be positive. It really doesn't matter which point you start at, but I'm going to start at the point 0, -1 and count. What's the change in the rise as I move from that point to the point 4, 4? I move up 1, 2, 3, 4, 5. So the change in the rise is +5 because I moved up. And then the change in the run from that would be 1, 2, 3, 4. So my slope would be +5/4. Find the slope of the line passing through the points -4, 6 and 3, -8. So one way you could do this is you could plot those points and count the change in the rise over the change in the run. Or you could use the formula slope, which is m, equals the change in the rise. So the rise deals with our y values. So y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So where does the y sub 2, y sub 1, x sub 2, x sub 1 come from? Well, we have 2 points. the first x value would be x sub 1. The first y value would be y sub 1. And so for the second point, our x would be x sub 2, referring to the second point. And then our y value would be y sub 2. So what we're going to do is substitute those values into the formula. So we have y sub 2, which is negative 8, minus y sub 1, which is positive 6, over x sub 2, which is 3, minus x sub 1, which is negative 4. So in the numerator, we have negative 8 minus 6, which is negative 14. In the denominator, remember, when you have a double negative, that changes to a positive. We have 3 plus 4, which is 7. And negative 14 over 7 can be simplified to negative 2. Our next example, we're asked to find the slope of the line passing through the point 7, negative 5, and 7, 9. And then the second problem would be find the slope of the line passing through the points negative 2, 6, and negative 2, 2. So what we do is label x sub 1, y sub 1, x sub 2, y sub 2, and plug it into our formula. Remember, our formula is m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So y sub 2 would be 9 minus y sub 1, which is negative 5, over x sub 2, which is 7, minus x sub 1, which is 7 as well. So in our numerator, we have a double negative, which changes to a positive. So we have 9 plus 5, which is 14. And 7 minus 7 is 0. So remember, if your denominator is 0, your fraction is undefined. So our slope in this case would be undefined. So the second example, again, we label x sub 1, y sub 1, x sub 2, y sub 2, and plug those values into our formula. So y sub 2 is 2, minus y sub 1, which is 6, over x sub 2, which is negative 2, minus x sub 1, which is also negative 2. So in our numerator, we have 2 minus 6, which is negative 4. And in our denominator, we have negative 2, and here we have a double negative again, which changes this to a positive. So we have negative 2 plus 2, which is 0 again. So in this case, our slope is also undefined. So notice the similarities. Notice that our x values for both of these were the same. So if our x values are the same, that means we have a vertical line. And remember, the slope of a vertical line is undefined. Graph the line with slope being 4 and our y-intercept being negative 1. So remember, our y-intercept is the place where our graph touches or crosses our y-axis. So we plot our y-intercept at negative 1. And our slope is 4. Whenever we're graphing, it's better and it'll make it easier for you to graph if you express this as a fraction. Because remember, slope is the change in the rise over the change in the run. So from that point, our y-intercept -1, we go ahead and rise 4 and then run 1 to plot our next point. Now we can do this as many times as we'd like because the slope's consistent as we move from one point to the other in a linear equation. So from this point, if we wanted to plot another point, we would also rise 4 and run 1. So next, we would connect these with a straight line. Our next example says graph the line with slope -3 passing through the point 3, -4. So the first thing we're going to do is plot our point 3, -4. So we move to the right 3 on our x-axis, then down 4 to plot our point. And remember, our slope is -3, which we're going to express as a fraction, -3/1. So from our starting point, which in this case is 3, -4, we're going to use our slope -3/1. So the change in the rise is -3, which means we go down 3, and our denominator is +1, so our run is the right 1. Now we could do this again, or we have enough where we can go ahead and draw a line through those two given points. In the next problem, we're asked to find the y-intercept and the slope of the line. So the easy way to do this, if you're given a linear equation, is to put it in slope-intercept form. So slope-intercept form, remember, is y equals mx plus b, where m is the slope and b is our y-intercept. So this particular equation is already in slope-intercept form, but it would be helpful if we actually put in the coefficient in front of x. When you just have that negative sign, that implies -1. So we have -1x plus 2. So remember, the slope would be the coefficient of our x, the value in front of x. So our slope would be -1, and our y-intercept would be 2, or as an ordered pair, 0, 2. Our next example, find the slope and the y-intercept of the line 6x minus 3y equals -5. So remember, our goal is to solve for y, so we can write it in slope-intercept form. Y equals mx plus b. So our equation is 6x minus 3y equals -5. So we want to isolate the y. So that means we need to move the x from the left-hand side to the right-hand side by taking its opposite. So that would give us -3y equals -6x minus 5. So in solving for y, we need to divide each term by -3. So this would give us y equals, now a -6 divided by -3 is a +2. And remember, -5 over -3, a negative over a negative is a +5/3. And we can't simplify that any further. So now we have it in slope-intercept form. So our slope in this case would be 2. And our y-intercept would be 5/3, or as an ordered pair, 0 and 5/3. For our next problem, we're asked to find the slope and the y-intercept, then use them to graph the line. So remember, we want to change this into slope-intercept form. So we need to solve for y. So we need to isolate, so we need to subtract 4x from both sides. And then divide by the coefficient, because we're solving for 1y. And -5 over +5 gives us a -1. So our slope would be -4/5, and our y-intercept would be -1. So remember the slope and your y-intercept. So next we come to our graph and we plot our y-intercept. That's the place where the graph touches or crosses your y-axis. And our slope is -4/5. So from our y-intercept, we're going to change in our rise being -4, so we're going to go down 4. And the change in the run is +5. Then we go to the right 5. Okay. Next, we just connect these 2 points with our line.